At any rate, translating both of these into Cartesian form, we wind up with a very famous result called de Moivre's theorem. In my high school, it was called de Moivre's theorem, but it's de Moivre's theorem, and it simply says that cosine theta plus I sine theta to the nth is cosine n theta plus I sine n theta. That result may not seem that remarkable to you, but let me give you another example using this result that shows how we can get real results using imaginary numbers. Let me take the special case n equals 2, just for the sake of argument. If I take n equals 2, this gives me cosine theta plus I sine theta squared equals cosine 2 theta plus I sine 2 theta. This says what? The real part of this is cosine squared theta minus sine squared theta. Again, it's I squared sine squared theta, which is minus sine squared theta. The imaginary part is 2 sine theta cosine theta. So if I square this, I get cosine squared theta minus sine squared theta plus I 2 sine theta cosine theta. By de Moivre's theorem, that equals cosine 2 theta plus I sine 2 theta. We saw that the only way that two complex numbers can be equal is if the real parts are equal and if the imaginary parts are equal. Comparing the real parts and comparing the imaginary parts, we get that sine 2 theta equals 2 sine theta cosine theta. Cosine 2 theta is cosine squared theta minus sine squared theta. Notice, by the way, that these are real results. And also notice, by the way, that even though these may look like old hat to you, I could just as easily, for example, I could have picked n to be 5 here, or 6. And in fact, I will do that in the learning exercises. The point being that what? I can raise this to the 5th power, compare this with cosine 5 theta plus I sine 5 theta, and wind up with real identities, in fact, for what? Sine n theta and cosine n theta for any whole number value of n. See, I'm trying to hammer home the fact that as we're doing the complex number arithmetic, don't forget that this stuff does have real applications, and we haven't even started to scratch the surface yet. This is just our baby lecture introducing the arithmetic of complex numbers. We haven't even got to anything like algebra or calculus yet. Wait till that happens, and you're really going to see some nice applications.